So we're going to look at this Cartesian geometry, coordinate geometry. So start off with a couple of basics that we should know. The distance formula is probably one of the first formulae we saw on the number plane. It's basically Pythagoras' theorem. Distance squared is equal to, or some of the other two sides squared. Let's do a quick example. Oh, look, we want to find the one between -1, 3 and 3, 5. Now, just a couple of misconceptions when you're using the distance formula. It actually does not matter which order you sub the numbers in. People get paranoid with this formula and think, well, because I subbed 5 in first here, I must sub 3 in first in the other one. And it doesn't matter, because of course you're squaring it. So if you sub them the other way around, you're going to get a negative, but you square it, you still get the right number. As long as you get the x values together and the y values together, that is, of course, the key. And we got 2√5 for that one. I suppose the next formula is our midpoint formula, which, as the name suggests, is the middle of 2 points, or the average. And so that's all you're really doing, is you're averaging the x values and averaging the y values. So in this case, we add them together and divide by 2, and there's our midpoint. So as I say, it's the average of the x and the y values. Okay. Well, that's the midpoint. But what's so special about the middle? I mean, we can find any other point we want in any other ratio. That's what we call dividing an interval. So tune it, midpoint's about as far as they go. Now, technically, it's dividing in the ratio 1 to 1, so it's nice and even. We can do it in any ratio we like, and it can be internal or external. So let's just define a few things so we know what I'm talking about here. There's an interval. Remember, an interval is something that has a definite starting and finishing point. So we usually incorrectly say, oh, that's the line xy, and actually, no, it's not. That's the interval xy, because it has a definite starting point and a definite finishing point. Now, A divides the interval in a particular ratio. So if I was to say it was m to n, that means the ratio of the distance from A to x, that part is m parts, and from A to y is n parts. So the naming of it's very important. They've said the interval is xy, the ratio mn. So you've got to keep it in the same order. Could, of course, said if we'd name that interval yx instead, then the ratio wouldn't be m to n, it would be n to m. So that's why you've got to make sure it's in the correct order. Now, that's what we call an internal division. If we were to produce the line to an external point A, I do it too, we say that divides it externally. But again, m to n means the distance from A to x would be m parts, and the distance A to y would be n parts. But that's an external division when A is on the outside of the two. All right, let's have a look at a few questions. We'll do it via HSC ones. So back in 2003, we had to find the coordinates of P, divides the interval, and joining 1, 3, 4, 5, 6 in the ratio 1 to 3. This is how I do it. I don't do it with a formula. First thing I do is I just write down the interval in the same order as they've named the interval. So, okay, -3, 4, 5, 6. And then underneath that, I'll write down the ratio, again in the order that they've said, 1 to 3. And then I just draw a cross. So how do I get my answer? I draw a set of parentheses with 2 vinculums separated by a comma. There we go. A vinculum is a fraction bar. Okay. Now, the bottom of the fraction is very easy. I just add the 2 numbers together in the ratio. So on the bottom of my fraction, I've got, in this case, 4. On the top of the fraction, I just write down the x values, but I multiply along the cross. So I'll have -3 times 3 and 5 times 1. And then I do the same for the y values. I just write the y values down, but I multiply along the cross. So 3 times 4 and 6 times 1 gets me my answer. Oh, that simplifies down. There it is. -1, 9 on 2. Well, how do you do an external division? What if that point's on the outside? Well, basically I do exactly the same thing. Okay, so I'm going to write down the points, 3 minus 1 and 9, 2. Write down the ratio, but here's where the difference is. I make one of those numbers negative. Now, it doesn't matter which one. I chose the 5 just because it was the first number, but I could have just as easily made the 2 negative. Draw in my cross, work out my point. So, bottom of the fraction, minus 5 plus 2 is negative 3. Write down the x values, but multiply along the cross. So 3 times 2, minus 5 times 9. And the y value, 2 times negative 1, and minus 5 times 2. And we get our point. Eventually, there is 13, 4. So that's how you do an external one. Exactly the same. Just make one of the numbers in the ratio negative. Well, what happens if they give you the answer, but they haven't given you one of the endpoints? So in this one, they've told us 1, 4 divides the segment interval. Joining A, they've given us that one, minus 1, 8. They just haven't given us B. So x, y, we've got to find those coordinates. The ratio is 2 to 3. So again, I'll do it exactly the same way. Write down the points, but this time the second point's x, y. I don't know what it is. Ratio is 2, 3. Draw in my crosses. But see, this time I know what the answer is going to be. I'm going to create some equations. So I'll do the x value first. So the x value, the answer, where is it? There it is. The answer is 1. So 5 will be on the bottom of the fraction, 2 plus 3. Then I write the x values down, but multiply along the cross. So minus 1 times 3 and 2 times x. There's an equation to solve. So eventually, okay, x is 4. I'll just do the same with the y values. The answer for the y values is 4. 5 on the bottom of the fraction, multiply along the cross, 8 times 3, 2 times y, and we get our y value of negative 2. So there's my answer. For negative 2. That's one way I could have done it. Another way I could do it is to change the question. The question at the moment says 1, 4 divides the segment or interval AB, and B is what we want to find. Well, I'm going to change the question. Right? So there's AB. B is what we're trying to find. They've told us P divides AB internally in the ratio 2 to 3. So I could change this question to say, well, that's the same as saying B divides AP externally in the ratio 5 to 3. Because P to A would be 5 parts, P to B would be 3 parts. And I'll just do it like the first ones. So write down the coordinates of the endpoints, which are now A and P. So minus 1, 8 and 1, 4. We're dividing it externally, so negative 5 to 3. Multiply along the crosses. So B will become, add the bottoms together, so minus 5 and 3 is negative 2. Multiply along the crosses. 3 times negative 1. Negative 5 times 1, there's the x. 3 times 8, negative 5 times 4, there's the y. And we end up with the same answer, 4, negative 2. So that's an alternative way. You can just rethink the question, make it something you're more familiar with. Okay, had to dig back a few years to find one of these. 1991. This time we've got to find the ratio. So they're giving us all the points, just on what the ratio is. Well, I'll set it up the same as before. The interval is 6, negative 4, 0, 4. The ratio, I don't know, but they've told me it's k to 1. They've told me it's external, so I'll write it as minus k to 1. And we know the answer. Okay, I really only need to do one of them. I don't have to do both the x and the y. Should work for either one. So I think I did the x, did I? Yeah, I set it up for the x. I know the answer is negative 3, so the bottom of the fraction is minus k plus 1. Then multiply along the crosses, 6 times 1, 0 times negative k. And we end up with 3k minus 3 is 6, k is 3. So I now know it's the ratio 3 to 1, externally in the ratio 3 to 1. All right. So we'll start with 5a.